This is GCSE Further Pure, and we're in Unit 6 Integration, and we're now looking at the area between a cubic curve and the x-axis. Quite often a cubic curve will then look like this, and so there's two regions that we need to find the area of. You just need to be careful, because if you integrate between b and a here, it's actually not going to give you a true answer. Remember we said last time that below is negative and above is positive. So say for example the area of this was actually 20 and the area of this was 15. That area would give us out as 5, whereas we know the actual area is 35. I hope that makes sense, because that's going to come out as a minus. That's going to come out as a plus, because that's a minus 20, and that then it'll just come out then as a minus 5, and so we'll think the area is 5. So we need to be careful about where this is crossing the axis and find this area separately to this area and work from there. So we actually really need a sketch of the curve, and that's why the example below then says that. So we just need to be careful of that. And here, you know, area 1 is in between 0 and A, and area 2 is in between B and 0, so we need to set it up like that. So we're going to sketch a curve. We've done one of these before, and then find the area between the curve and the negative x-axis, giving answers to 2 decimal places where necessary. So negative x-axis isn't actually what we're asked for here, but we'll work that out whenever we come to it. Okay, so let's make a start then on our example 1. There's a fair bit to do with this one. So we're going to sketch our curve. So our three things are where it first of all crosses the x-axis. It crosses the x-axis whenever y equals 0. That means x cubed minus x squared minus 6x equals 0. Don't know if you remember, because there's a common x in this particular cubic, we can take that out. X squared minus x minus 6 equals 0. That means either x is 0 or x squared minus x minus 6 equals 0. This factorizes, nice straightforward one with a single x squared. Two numbers that multiply to give minus 6 and add to give minus 1 are of course then going to be x minus 3 and x plus 2. That means x minus 3 equals 0 or x plus 2 equals 0. That means x is 3 or x is minus 2. So we have 0, 0 is 1 point here, 3, 0, and minus 2, 0. If we were finding our areas, those would be then the limits that we would be integrating between. Crosses the y-axis. Whenever x equals 0. So y equals 0 cubed minus 0 squared minus 6 upon 0, nice and straightforward. We have 0, which of course is our point then 0, 0, which you already had. Obviously if it's going 0, 0, it's crossing there at that point. The next thing we find then is our turning point. How do we find our turning point? Hopefully remember we're going to find dy by the x. Turning point is whenever dy by dx equals 0. That's with the gradient 0. Of course the gradient is horizontal at the turning point, so we can work out then from there. Dy by dx in this case is going to be 3x squared minus 2x minus 6, and we're going to set it equal to 0 for the turning point. At turning point, dy by dx equals 0. So 3x squared minus 2x minus 6 equals 0. This one doesn't factorize, so we're going to have to use the formula. So we'll be putting in then a equals b equals and c equals. Our a is 3, our b is minus 2, and our c is minus 6. And we're going to be using an x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Again, you should be well versed with that and know how it works. So our x then is going to be minus minus 2, so it's 2, plus or minus the square root. Be careful here, minus 2 squared of course gives us 4. Take away 4ac, so 4 times a is 12 times 6 then is going to be our 72, but it's actually going to be a plus 72 because our c is a negative. 3 times the minus 6 is minus 18 because we have a minus in there. then all over 2a, which is 6. So we have x equals 2 plus or minus the square root of 76 all over 6. That gives us two values. That gives us x is 1.786 and x equals minus 1.120. I hope we have a bit more space here because we have more to work out. We have found the x coordinates of the turning points. We now need to find the y coordinates of the turning points. So at x equals 1.786, y is 1.786 cubed minus 1.786 squared minus 6 upon 1.786, which equals minus 8.21. At x equals minus 1.120, y equals minus 1.120 cubed minus 1.120 squared, so it's minus 1.120 squared, then minus 6 upon minus 1.120, and that I'm led to believe gives us 4.06. So those are our coordinates now for what we're looking. So 1.786 minus 8.21 minus 1.120, 4.06. We now need to find whether they are maximums or minimums, so we're going to use d2y by dx squared, which in this case then is going to be 6x minus 2. At x equals 1.786 d2y by dx squared. So if I put 1.786 in there, 6 times this, take away 2, I don't know what it is, but I know it's positive. Therefore, it's a minimum turning point at 1.79, just doing a wee bit of rounding there, and minus 8.21. Of course it is if you think about the coordinates, but that's fine. At x equals minus 1.120 d2y by dx squared. Again, I don't know what it is, but 6 times a minus, take away 2, is definitely going to give us a negative. So that's going to be a maximum turning point at minus 1.12, 4.06. So we're now at a stage where we can sketch our graph. We have enough information then about it. So let's get a wee diagram done here if we can. So here's my x-axis. Again, make it nice and thick for these lines so you can see I've actually drawn something on. And then my y-axis, which is going to be here. And again, it's a sketch, but we just expect you to do it reasonably neatly with the key points on it. So 2, it crossed here at 0, and then it crossed at 3. One of my turning points is minus 1.12, 4.06. So round about here, and let's go up to here, I think. So if we go minus 1.12, 4.06, that's that coordinate there. Our minimum then was 1.79 minus 8.21. My scale's not great here, I hope you'll forgive me. So if we go down to there, minus 1.79 is just over halfway, I suppose. So that would be minus 1.79. So that's a positive 1.79, that's a wee mistake there. And then, of course, the y coordinate's negative, minus 8.21. And let's see if we can draw some sort of curve here. So that's not bad, and that's worked out okay. Now, I don't know if you remember the question, but for part B, it asks us, find the area between the curve and the negative x-axis, giving answers to 2 decimal places, if necessary. That actually meant for part 1, but that's okay. We should be able to get this to an exact figure for us for that. The curve and the negative x-axis here, of course, is our x-axis. Here's our y-axis. The negative x-axis is here. So the bit that we're looking for is actually just this bit. Sometimes you might be asked for both, in which case you need to do this bit separately, between 3 and 0, and then 0 and 2. But the one we want is the one between 0 and minus 2. Sorry, 0 and minus 2. So let's go about doing that. Again, we'll take down what we have there. So we have curve and negative x-axis means the limits are minus 2 and 0. So we're going to find the area in between 0 and minus 2. It's always the biggest number on the top, which of course 0 is in this case. X cubed minus x squared minus 6x dx. The area then is equal to x cubed over 3 minus, sorry, that's x to the power 4 over 4. I can't integrate. Add 1 to the power, I'm losing my mind here. Add 1 to the power 3 divided by 3. And I'm just actually going to do this whole thing. It's going to be add 1 to the power, which is 2 divided by 2. So that means 6 divided by 2. So it's going to be 3x squared. Hope you're okay and that wasn't too much for you there. And it's 0 and minus 2. Our area. Putting 0 in here, here and here is just going to give me a 0. I hope you're okay with that. It's just the negative bit we need to worry about. So putting in minus 2, it's minus 2 to the power 4 over 4 minus minus 2 to the power of 3 over 3 minus 3 minus 2 squared, and we close up our brackets. That gives me an area equals 0, of course, take away. Minus 2 to the power 4 is positive 16 divided by 4 is 4. Minus 2 cubed there, but that's a minus and a minus, so it's actually going to be a plus 8 over 3. Minus 2 squared, let me see, is going to give me 4 times the minus 3, then is minus 12. Be careful with that one. So that gives me an area, I'll move down a bit, of 0 minus, and then that gives me minus 5 1/3. It's given me a positive answer, which is good because it was above the axis, so that seems right. And x then is 5 1/3 square units.